Hello everyone, welcome to this quick video presentation on IRIS regular expression for language standardization. This video is part of the Tata Memorial Center Unit for Strengthening Cause-of-Death Data in collaboration with CDC Foundation. My name is Mrs. Swati Sangle. I am working as the IT consultant with the CDC Foundation supporting data for health initiative activities in India. I support the IRIS implementation and maintenance activities in MCGM through the Unit for Strengthening Cause-of-Death Data based at the Tata Memorial Center, Mumbai. This video explains regular expression which is designed for users of IRIS software. Let's start with regular expression. Firstly, what is regular expression? Regular expressions are standardized strings to enable the search for specified text strings. They are widely used and can be embedded in many programming languages. Some programming languages use slight variations of regular expression. The most important part about using regular expression is to clearly define what text strings you are looking for. If you do not exactly know what the result of the search should look like, the regular expression you will use might not be precise enough. Before formulating a search through a regular expression, you should clearly define the string you are looking for and as well the strings that should not be matched with your regular expression. Otherwise, you might find that the search gives you the results you wanted plus some additional text strings. A key part of IRIS software is the language standardization through regular expression. IRIS standardization rules. IRIS employs rules to standardize the text of causes of death. A standardization rule is made up of two filters. The first filter is filter in, includes a regular expression that will be used to identify the context. The second filter is filter out, which replaces the context when it is recognized. In string in field, strings to test the standardization filter in context. IRIS now applies the filter to the text strings in and displays the output in the string out field. The result field is shows context is successfully identified or not. You can use filter in and filter out to change and correct a rule. Once the rule works correctly, you can add it to the standardization table. These rules are written by the user and are depending on the languages with which causes of death are declared, like Swedish, German, French, and more. IRIS standardization rules can be categorized in two classes: modification rules and deletion rules. Modification rules uses a filter out field. When the regular expression in filter in matches with a string, what is recognized by regular expression is replaced by the content of filter out. For instance, as shown in slide, the context malignant neoplasm will replaces by cancer. The result is a successfully match. Deletion rules. In case of deletion, filter out is empty. A first type of deletion consists in discarding a specific word. For instance, if filter in contains the expression probable and filter out is empty, all the occurrence of the word probable will be discarded from the causes of death text. Now we go through regular expression elements. First is text. Text strings can be matched by entering just the text string itself. If a certain string of letters should be detected, no matter which place it holds in the text, it can be entered without any additional meta characters. For example, you would like to find all text fields containing the string heart. You do not worry about the position in the text. Therefore, a search with the text heart would be sufficient. The result will match with words like heart, insufficiency, weak heart, hearty, and more. Backslash or escape character. In regular expression, the backslash can be used as the start of a meta character. Some characters called meta character have a specific meaning in regular expression. For instance, plus is a quantifier, dollar marks the end of a line, dot stands for any character. If it needed to use one of these characters with its usual meaning, it is necessary to escape it. This is done with the meta character slash, followed by specified other characters. A specified meaning in regular expression can be expressed. If a character itself has a specific meaning in regular expression, it has to be escaped by a backslash in order to be used as the character itself. Whenever you use backslash, you have to ensure that slash is also used to change some normal characters into meta characters. For example, slash w means any letter and w is the letter w. Slash being a meta character, it must be escaped to express a normal backslash like slash slash. Space element. To match one white space field in a string, use slash s. There are other ways to express white space as well. For example, square bracket. Still, to achieve better legibility of the used regular expression, one should stick to one way of formulating the regular expression, and slash s seems to be a good way to express and read regular expression. For example, develop a regular expression to match the string Peter was sick. Peter was sick slash dot would be sufficient, but it is better to use slash s constantly in order to avoid inconsistency. Way of writing the expressions Peter slash s was slash s sick slash dot would be preferable. The space element slash s used between the string. Word boundary. To start or end a word, you can as well choose from different approaches. The predefined regular expression element is slash b. It marks the start of a word as well as the end of a word. How do regular expression know what word boundaries are in different languages? As word boundaries might be different in the various languages, slash b matches the position between alphanumeric characters and underscore and other characters. For instance, create a regular expression to match the word heart. The word heart attack should not give a match, as there is no limit given to how the word should begin. The regular expression could start with just the word heart. Still, the question asks for the word heart without attack afterwards as a part of the word. So, regular expression is heart slash b, where slash b defines the end of word boundaries. The symbols dash, colon, semicolon, plus, and so on are word boundaries as well. So if you would like to match words containing word boundaries like the dash, should be careful how to set the word boundaries. Characters. There are two different groups of characters defined through regular expression that should be described now. Digits and words. Digits are expressed through slash d. Slash d recognizes a digit between 0 to 9. The string 1 to 3 can be written as slash d slash d slash d. Each digit needs to be expressed by a slash d, as represented only one digit. The combination of all letters, the underscore and all digit is expressed through slash w. For example, create a regular expression that matches all of the following strings: diabetes type 2, diabetes type 1, diabetes grade 1, diabetes grade 2. The regular expression is slash B diabetes slash S slash W slash W slash W slash W slash S slash D. Slash B is used to define the boundary of a string, a space within a string. Slash D is used to define digits 1 or 2. And 4 times slash W is used to define 4 letters word type or grade. It is most important for you to know in IRIS only the regular expression with lowercase character should be used, as the system does use all words in lowercase writing and it might cause confusion to use regular expression with uppercase and lowercase sensitivity. All these regular expressions use lowercase characters. If you use the uppercase characters, it expresses the negation of the meaning it has with the lowercase letter. For example, in lowercase slash s gives you white space character. In uppercase slash s gives you anything but a white space character. In lowercase slash d gives you a digit. But in uppercase slash d gives you anything but a digit. Dot element. A very broad meta character in regular expression is the dot. It matches any single character. As the dot is very unspecific, it should be used with great precaution. In IRIS, there are hardly any uses for the dot, and it should be avoided whenever possible. Please note, if you want to match dot in a string, you have two ways to express it. As described, any meta character can be escaped through a backslash. To match a dot, you can enter slash dot in the regular expression string. This way to express a dot is easy to read in IRIS. Another way to match a dot is to put it in square brackets. Whichever way you choose, you should stick to this version in order to avoid confusion. Start of a line and end of line. As mentioned before, the boundary of a word can be defined through slash b. There are two other special characters to define the boundaries of a whole text strings. In IRIS, this would mean the start or end of a line. The start of a line could be expressed as a kreta symbol. The end of the line can be expressed as a dollar symbol. Significantly, you would like to match the string in the morning at the starting of the line. The exact regular expression would be kreta in slash s the slash s morning. If the text string should be at the end of the line, the correct regular expression would be in slash s the slash s morning dollar. Set or range of characters. To define a set of characters, use the square brackets. Within square brackets, you can give a number of characters which match a single character in the string you are searching in. Sets of characters can be given through enumeration of characters. Here are some examples to show you how you can write sets of characters. The square brackets EFG matches the E, the F or the G. If you write plus minus in square brackets, it matches plus or minus. Also, when you written in square brackets A, B, Z, 3 matches the A, the B, the Z or the 3. Ranges. A range of character can be given through the starting and ending characters and a minus sign in between. In square bracket, A minus Z matches one character in the lowercase alphabet. In square bracket, 3 minus 6 matches the 3, the 4, the 5 or the 6. Also, when you write in square bracket A minus GM minus P matches one character in between A and G or in between M and P. Note that character sets in square bracket may be negated using the creta. For example, in square bracket, creta S minus Z matches anything except S to Z. Create a regular expression to match all the following words: arteriosclerosis. As physicians sometimes use different ways to write the word, you might find it helpful to have a regular expression like the one for this example. See here, arteriosclerosis. Here, C or K used in a square bracket and E or I used in a square bracket. This will help you to reduce the size of the dictionary. Using set or range characters, you can redesign your regular expression to be more precise. Diabetes type 2, diabetes type 1, diabetes grade 1, diabetes grade 2. The regular expression is diabetes slash s in square bracket a minus z 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 slash s in square bracket 1 2 would be more precise. Create a regular expression to match all the following words: burn grade 1, burn grade 2, burn grade 3, burn grade 4. The word burn and grade are the same for all text, just the number varies. So, regular expression is burn slash s grade slash s in square bracket 1 minus 4. You would like to identify all strings that contain the word ball or fall. Again, the identical part of the word can be identified all. Always look for similarities in the words you would like to match first. The first letter should be B or F. So regular expression is in square bracket B, F, all. Quantifiers. It is possible to quantify the number of uses for a meta character, set or ranges of characters in regular expression. Therefore, a couple of symbols are used. First is asterisk for 0 to n elements, which matches 0 to endless repetitions of the previous character. Dot asterisk will recognize any number of any characters include an empty string. For example, matches none or 20 or any number of the following white spaces after the word heart. You can write regular expression like heart slash s star. Second quantifier is plus for 1 to n elements, which matches one or more repetitions of the previous characters. Slash w plus will recognize a word including letters, digits and underscores, but not hyphens. For examples, create a regular expression to match the following content. Find all words that start with heart and do have some other words component afterwards, like heart attack or heart failure. The regular expression is heart in square bracket a minus z in square bracket a minus z in square bracket a minus z plus. Plus quantifier defines one or more number of words after the word heart. Third quantifier is question marks for 0 to 1 elements, means matches 0 or one single character. Character S question identifies 0 or 1 S. For example, match with lung or lungs. The regular expression is lungs question mark. Example 2. Create a precise regular expression to match all the following words: multiple, multipla, multiple. The regular expression is multiple in square bracket AE question mark. Repetitions of characters can be quantified individually as well. In curly bracket, A, B defines A to B elements. If B equal to A may be written in curly bracket A. In curly brackets, a number of uses can be given. Additionally, the starting and ending amount of a character can be defined by giving an range in curly brackets. For example, A in curly bracket 3 specifies the use of a 3 consecutive times. A in curly brackets 3, 5 specifies the use of character a 3, 4 or 5 consecutive times. If only the first number in curly brackets is given followed by a comma, the range starts at the number given and can be endless repetitions like A in curly bracket n, space. Let's see some examples on repetitions of characters. Create a regular expression to match any string that contains 3 digits. Now you know how to quantify a certain number and your regular expression gets shorter /d in curly bracket 3. Create a regular expression to match the European zip codes. There might be 1 or 2 letters in the beginning of the string. Then there has to be a minus. Afterwards there are 4 or 5 numbers. So regular expression a minus z in curly bracket 1, 2 in square bracket minus /d in curly bracket 4, 5. Create a regular expression to match the NYHA grading in Roman 1, 2 and 3. NY is the stable part of the word, so regular expression is NYHA slash S in square bracket I in curly bracket 1, 3. Alternative. The vertical bar character means or. For instance, A vertical bar Z means letter A or letter Z. It is the same expression as AZ within square bracket. Vertical bar expresses an alternative between what is on the left and what is on the right. For example, cancer vertical bar neoplasm of liver will matches with both cancer or neoplasm of liver, but not with cancer of liver. If they aim to match with cancer of liver or neoplasm of liver, use parentheses to limit the scope of alternative. So, in this case, your regular expression will be in parentheses cancer vertical bar neoplasm of liver is the right expression. Sub-expressions or parentheses. Parentheses group elements together. For instance, if one wants to apply a quantifier to several elements, parentheses are necessary. It can be used to identify parameters. Sometimes, for example, in order to define expressions within a string, it is necessary to define strings within round brackets. For example, matches all words that contain the syllable heart in the middle of the word. The regular expression is /w asterisk in round bracket heart /w asterisk, which matches all words that have the letters H, E, A, R or T in the middle of the word. Sometimes it is necessary to define a number of possible words in one regular expression to keep the amount of regular expressions small that are used in standardization table. The strings in the brackets do not match a string in the text as opposed to the characters in the square brackets, which match only one character in the text. Parameters. Sometimes it is necessary to keep parts of the expression as it is after the standardization is applied. If you have to match the string in through a couple of different meta characters which should stay as they were, you have to define them in a variable way in the filter out. Again, one uses the brackets in order to define the string in. The part of the string contained in brackets is kept as a variable. In the string out, this part can then be specified as $1, $2, $3 and so on, depending on which position in string it was. For instance, you would like to substitute the abbreviation CA dot in several strings which contain the localization of the cancer as well. CA dot of liver, CA dot of heart, CA dot of skin. The regular expression would be CA slash dot slash S of slash S in round bracket liver or heart or skin round bracket completed. For the substitution, you would like to keep the localization as it is and just modify the CA dot part. Therefore, you formulate the string that should be used after standardization as well. Cancer of $1. $1 defines the part in the brackets. So if the text was CA dot of liver, cancer of liver will be substituted. But if the text was CA dot of skin, it will be transformed to cancer of skin. The dollar has the number 1 because it is first parameter used in the stringing. If there are more than one parameter used in the line, the enumeration of dollar is used as they appear in the search text. The information presented in the video comes mainly from the IRIS website Wikipedia that is available on the link presented on this slide. I hope you find this short introduction video on IRIS helpful and hope you consider watching the other IRIS and informational videos we have developed and posted on the YouTube channel for the unit for strengthening cause of dead data. Thank you.